Hello everyone, this is Javed, Lecture Mathematics, International Maritime College. After Cramer rule, our next application of matrices is Gaussian elimination techniques. With the help of this, we also solve system of linear equation. It has certain stages to be understood first, and at the end we apply all the stages together in one problem or in one question. So let's go through the stages one by one. Number one will be augmented matrix. What is augmented matrix? First I'm giving you say outcomes. Number two, what types of solutions are there, or how many types of solutions are there of linear equations. Then we will understand row echelon. Some people, some mathematician pronunciate is ka, echelon, and some pronunciate it like echelon, shy. If you know the word shy, shy. We in Pakistan call chai. You in here in this culture you call it shy. So it's like echelon form. So what is echelon form of an augmented matrix? And then elementary row operations. When we complete all these four things, then we will be ready for application of this technique. Number one, what is the augmented matrix? This is a system of linear equations, two unknowns, two equations, two unknowns, x and y, two unknowns and two equations, 1 and 2. If we have 3 unknown, there will be 3 equations. Okay, remember in the Cramer rule we used to have 3 matrices of this kind of equations, but here we get only one matrix. Yes, and it is simply removing these equality symbols. Yeah, so look, when we remove equality symbols and take coefficient 2, coefficient 3 and 6, so it gives us the first row. The same way, if we remove this equation symbol, here it is 1, here it is 1, so minus 1, and this is minus 2, so second. We call it augmented matrix. Let's have a system of 3 unknowns, or a system of 3 linear equations. So with the same pattern we remove equality symbol and take coefficient on the left side. Here it is minus 1, 2, and on the other side, so it is first row of the augmented matrix. Here 4, y doesn't have something, so it will be 1, and at this position we can write is 0 z. So look, I have written here 0 for z, and then 6, here 1, then 2, then minus 1, and at the end 2. So this is augmented matrix. So augmented matrix concept is simple. Now, types of solutions to the system of linear equation. There are actually three types of solutions. First are cases. First, unique solution. Unique means there will be only one answer, one solution. Unique means this. And infinite means there are a lot of solutions, and no solution means nothing. Well, so if we have this kind of system, so if we look at the second row, it simply gives us y equals 2, and then we plug this value in the first one. So x plus 3 and 2 equals 7, and this will give us that x equals 1. So look, x equals 1 and y equals 2, they are unique solution. There are no other value of x and y which could prove these equations. If we plug here in this one the x value and the y value, so 0 and 1 plus then y value which is 2. So you see this comes 2, which is this 2. And if we plug here in the first one, so 1 plus 3 and to y value, this is y, equals 7, which is this 7. Well, now let's come to the infinite. This is my slide work. Okay, I'm going to clean this now. Okay. Some of it I'm going to clean, right. Then let's move to the second case. Second case, you see the second equation gives us 0 equals 0, which means yes, 0 equals 0, so everything fine. Then what about this one? Which is x. So I'm going to find x from here, so it will be 7 minus 3 y. So we don't have answer for y, so what we do, we suppose let y equals t. When we suppose y equals t, then x will be equal to x will be equal to 7 minus 3t. Now look at this thing. if we how many value of t we can take? We can take 0, we can take 1, 2, 0.5, and blah blah blah. Okay, so even if you want to take -1, you can negative side as well. Lot of values here. So if I use the first one, so y equal to 0 and x will be equal to 7 minus 3 into 0 equals 7. I'm here. Okay, if y equals, because all the time y equals t, so they are t. So if I take 1, then x equals 7 minus 3 and 2, 1, because t is 1, equals 1. And it is up to you how much and how you are taking y value, and with that respect the x value will be coming. So infinite solutions are coming. Now look at case 3. Okay, so this is my slide work. Okay, and this is augmented matrix here for the first case, because we need augmented matrix, so I am trying to repeat you augmented matrix so that you could learn it. So augmented matrix for this is 1, 3 and 7 here. The last one 0, 0 and 0, so 0. So augmented matrix. Now let's come to third case. I have another equation. In this system of equations, the second equations tell me that the left side is almost 0 and the right side is equal to 2. So 0 equals to 2, it doesn't make sense. So it means this has got some problem, so it means no solution is possible here. X and y doesn't have value which could give us these results. Let's go to next slide. Oh, this is augmented matrix. Now let's go for an example. Solution of a system about these three cases. So the second line or the row tells us that there is no x because x is 0 and y is 1, so y equals -3. Now we plug in this value in the first one, so x minus 4 into -3, because y is 3 equals 13. This first column represent x coefficients and they represent y coefficients, and in augmented matrix they are the right side of the system of the linear equation. Right side means after the equality symbol. Well, if we do it, the x value will come out is how much? This comes plus 13. When we change side for this, it becomes plus 12. So when we change side for it, it will become minus 12 and equals 1. So it has a unique solution. No other values of x and y possible to bring this answer. Now let's see my slide work. So yes, I told you that here I took the second row. Let me change the color so that so look, this is second row which sorry, second row means this one. So I got this first equation, and which will give us value y equals minus 3, which is here, which I explained already. Now we will plug in this value in the first row, and this is first row. So if we put here this y value, this will be the situation. Then x value will, or the first equation will become this way, then it become 12 as I explained earlier, and this is x value. So it has unique solution, x equals 1, y equals minus 3. Sorry, I forgot to write the page number. This is 600 and let me see the book. 600 page 594, page 594. Okay, and I have given the reference of the textbook. Here it is reference. On each side I am giving my book reference. Right, let's go to next example. Next examples, if we look at row 2, so 0, because x is 0, y is 0, so the whole left side is 0, equal to 4, and this does not make sense. How 0 can be equal to 4? So we say that this does not have solution. It doesn't have any solution. This is case 3 we discussed. Okay, sorry I'm forgetting page number, but I think you will you can see this from your book. Okay, so solution, look, this equation has no solution, as I explained earlier that 0 cannot be equal to 4. Let's go to another example. On this example, if we look at here, the second row, so 0 the left side, because x and y both 0, so it equals 0, and the right side of the equation is 0, so equals to 0. Yeah, so things look pretty good. So we should proceed now, and now so I already explained this is equal 0, so this equation is satisfied, true. Let's go for the first one now. So the first one, if we look at this, this is x plus 3y equals 17. I think we did this kind of simplification first. So now x can be written as 17 minus this whole term will be shifted to the other side and it will become 3y. And now you see y doesn't have any value, so for we take okay, so what we do, we take, let suppose y is t. When y is t, then on the basis of our supposition the x value will be equal to 17 minus 3. Now for y we will write t. So y t has lot of values, so this way the x value will become infinite. Now let's see my slide, neat clean work. Yeah, so 17 minus 3t and y equals 2. So this is actually general solution, we call it general solution. Okay, in case of infinite solution we write general form. Example 3.5. This time I am taking an example of 3 by 3 matrix, 3 by 4 matrix, augmented matrix. So the same situation is here. Look at row 3rd, x 0, y 0 and z is 1. So z equals minus 1. Well, now we plug this value in it. This is y minus 4 into z. Okay, because 4 is z, so with 4 I will plug in value. Minus 1 is 7, and this provides us y value equals I think 3. Yes, we got calculators, thanks to calculators. Okay, so I'm writing a little bit awkward. So thanks to calculators, and this answer is 7. Now for the first row we don't know x is 1, here it is y, so I'm short of space, so I should control myself. Okay, so plus it is the most difficult case for me to write 2 y is 3, then plus z is 2, so 2, and the z value is here, which is minus 1 equals 11, and this provides us the x answer. This comes out 6, this comes out minus 2, so 4, and if we change it, so 11 minus 4 is I think 7. So unique solution, x, y and z. Now let's see my net and clean work. Third row is equal to -1, which provides z equals -1. Second row is this. When we plug in z value, and it gives y values 3. We did 3, good. Now go for the first row, plug in y and z, and it gives 2. Oh my god, what happened? So 2, 3, 6 and 4. What is wrong? My answer there is 7, y7, 2 and 2, 3, 6, and this is, I'm taking, I think, 3, and here it is 2. So maybe I have done mistake here. First row, let me see the book. Yes, so the mistake is here. This is -3. This is -3. Okay, so I'm going to correct it now. So this is -3. Also, let me raise this value. So this is one more. We got -3. I should write there. So now this is 236, and this is this is 3, 1, so 6 plus 3, 6 plus 3, 9, and 11 minus 9 is 2. So yes, my neat work was fine. Okay, only thing is, please correct this thing. This is not 2, this is -3. Well, now the third outcome. The third outcome is row echelon form. This is little tricky. You need to pay attention. Echelon form, whenever in augmented matrix, all, this mean all, sorry, entire mean all. And all values are 0. Like you see here 0, here 0, but here not 0 in this case. So we will discuss this later. So when this situation comes in echelon form, the last row, this is first row, and this is second row. Don't forget the basics. And we, like, if I draw this pattern, we call them rows. And if I change color and show you this and this pattern, we call them columns. Okay, so this was a reminder, a recall actually. Well, next point, the echelon form he's got one special number which we call leading one. Okay, leading one. So what are leading one? Okay, this is a big lesson actually today. Look, the first element of the first non-zero element of a row is called leading one. So here it is leading one. One, of course, come leading means the leader. Here we don't have leading one. In this matrix, one is leading one. This is leading one. Second row has got one, first non-zero. From the left actually we count. And the third row doesn't have leading one. In this matrix, leading one is here. This is got leading one. This is got leading. The first non-zero element of a row is called leading one. Now something about the leading ones. When we move down in a matrix, the row of the matrix means coming down, the leading ones move to the right. Like it has one leading one, in the other column is 0, so this is fine. It has leading one. In the second row, the leading one has moved to the right. In the third matrix, leading one is here. Now in the second row, you see the leading one has moved to the right, and the third one, the leading one has moved more to the right. And note that when the leading one is moving to the right, on its left there will be zeros. On under it, it will be 0. So on the left of it, it will be 0, and the right of it will be 0. Okay. So the leading one has a strange pattern. It appears in a matrix in this shape, like stairs. Okay. Sometime leading will be here. There can be 0, there can be 0, there can be 0, then leading will be there. Then after this there should be 0, 0, 0, then after this leading one there must be 0, and it can be leading one. There can be zeros, yes, and leading one can come here. So the more we go to left, the more we come down, the leading will move to. So at the same time, when we are coming down, the leading one will jump to the right. When it comes one down, it will also jump to the right. This nature of this non-zero element, the first non-zero element, are called actually this is the nature of the leading one element. Okay, let's have an exercise, I think, on it. Does it have leading one? Yes, the first row has got a leading one. Now under it 0, fine, and the leading one is here. So under it there is no row, but the left of it is 0. So okay, let's take another example. It has got leading one, yes, but under it there is no 0. So this 0 is okay, but under it there must be 0. So this is not an echelon form, and this is echelon form. See more. This is leading one, yes, fine. Under it 0, fine. If it is not leading one, no problem. All can be 0. This is the first characteristic of the previous slide. So yes, it is an echelon. With this is leading one, yes, under it all zeros, fine. About this one, all left, this left and this left 0, and under it this 0, fine. What about this one, leading one, all left 0 and under it no column, so this is also echelon form. So this is about echelon or echelon form. So this is you can try. What about this? What about this? This is leading one, yes, this is leading one, under it 0 and left 0, so this is echelon form. This is first leading one and this is second leading one in the next line to the left of this 0, okay, this is echelon. This is first leading one. Is it leading one? No, because under the first leading all the elements should be 0. This is not fine, so this is not leading one. Yes, what about this lead? This is leading one, yes, all element under it 0, and it does not have leading one, okay. But what about this leading one? Is it leading one? No, because on it this row should have leading one, which should come to the left above this leading one. So this is not leading one, this is not echelon. Well, this is fine because all under it are 0. Look at this, all this is 0, left 0, but here not 0. So this left, down and diagonal all elements should be 0, so this is not leading one, so this is also not echelon form. You can see the result also on the book. I will upload this. Okay. Now elementary row operation. What does it mean? I will explain this with the help of common example: multiply, divide, add, subtract. So see, there is in this is example. So the augmented matrix of this is 2, 1, 5, 1, 12 and 3. So this is augmented matrix, okay. Come to part B. Part B says that interchange the rows. So 1, 1, 3, 2, 5 and 12. So add means we did a row operation, and what we did here, we interchange row 1 with row 2. So this is example of interchanging operation. So we can interchange rows, and we are only working on rows, so you should limit yourself to rows. I'm not doing example on columns. First we should learn rows, and I think I should not take the column one. This one is enough. Okay, now what do they say? That part 2, I lost my cursor, where is it? Okay, now I'm here. Multiply, subtract 2 times the first row. It means first row 2 times from the second row of okay, this is from the second row, so I make it clear, this is 1, because subtract 2 times of first row, so this is first row. So add means what? Add means I'm doing on this matrix, augmented matrix, so we are changing to the second row. The first row is not changing, so 1 1 and 3. 2 minus 2 times of first row. The first row here is got 1 element, so this is 1. Okay, now here it is 5, so I will write 5, then minus, then we will apply this thing, 2 row 1, so the row 1 here is 1, so we will write 1. Now coming to 12, so 12 minus, again this thing we are doing because they told us do this, 2 and 2 R1, which is this element, and this will give us 1 1 3, this will be 0, this will be 3 I think, and that will be 6. So we did this row operation. Now they are asking us for division. So divide second row by 3, again this matrix, second row, divide second row by 3. Okay, so first row is 1 1 3, 2 divided by 3. Now second row it is 5, so 5 divided by 3, and this one is 12, so 12 divided by 3. So part third is done. Okay, but let's see my explanation neat and clean. Okay, so it looks similar. I should change color so that we can differentiate easily. Okay, so see this and the same. Okay, this is part 1, which is here 1 1 3 2 5 12. Okay, part 2 1 1 3 0 3 6, so 1 1 3 6. Okay, why part 3 is different? Divide second row by 3, second row by 3. So here I should have supposed the previous answer, the answer of the second. So this one I'm going to correct. Okay, this actually this is communication problem. They should have told us they divide this in part 2. So this is communication problem. No problem, no way. They should have make it clear. I should have make it clear. Okay, in 2, but I did what? I used this matrix. So if we are going to correct it again, I'm going to clean it. Oh, no need to clean, I have space, so let's do it here. So into the matrix is this one, so 1 1 3 0 divided by 3, because they are telling us to do by 3. Then the next is 3, so 3 divided by 3, and this is 6, then 6 divided by 3. So it provide note one thing, that in matrices we do not use symbol equal, okay, we use symbol like this wave type symbol, right? So this is 1 1 3, this is 0 1 and 2. So this implies that y equals 2, and this implies that x, because we don't know x here, and now this is y, so plus 1 and to y value equals 3, and this gives us x equals 1. I also finished part C because they were asking solutions. So this is now part C. So row operation, you see, convert a system of linear equations to echelon form, and from the echelon form we can go for solutions easily. Okay, so solution my network. If you want to see the network here on the video, I supposed to clean them. Okay, substituting y equals 2, this y equals 2 is here, which is here, and then x equals 1. So the answer is, it has a unique solution, x equals 1, y equals 2. You please try this for use Gaussian elimination to solve it. Hello. Okay. Example. System of linear equations. I think we can get the augmented matrix now easily. Okay, so we need to reduce this to echelon form. Echelon form is that where you have leading one situation, so leading ones. So we need to produce leading one in each row. So first here like this row operation is done. Okay, so the row 1 from this -2, from this -3, because this is row 2, and from this -19, and row 2 we are doing row operation on 1, so row 2 is not changed. Now next, after simplification, this is 1, this is minus 4, this is minus 18. And now we need to make it leading one. To make it leading one, so the under it number should be made 0. So what I do, from row 2, this is row 2, 2 is row 2, I'm going to subtract row 1, which is 1, but only 1 will not work. I multiply this with 2 and then subtract. So see, 2 minus 2 row 1, 3 minus 3 row 2 row 1 elements, and 19 minus 2, this is 19, minus 2 and minus 18, which is row 1 elements, and this will give us, so yeah, we succeeded to convert this into leading one, because under it is 0. Now we need to convert this to leading one. We need to make it 1. Simple, because the left is already 0. So we divide this by 11 and it will become 1. So what we do, we divide the whole row 2 by 11, because we cannot do operation to a single element. If we do some operation, we will do this to the whole row. So 0 by 11, 11 by 11, and 15 by 11. Why divide by 11? Because this is 11. Well, and it comes this. Now this is echelon matrix. Look, this is leading one, under it 0. This is leading one, on the left of this 0, and under no rows. Okay. Now we are ready for solution. The first I'm going to change color. Okay, this is, they are coefficient of x and they are coefficient of y. So if we look here in the second row, so the x is 0 plus the y is 1, so it means 1y or only y equals 5. So this implies that y equals 5. Now let's go to the first one, the first equation or the first row. So it is 1, so it will be x, then minus 4, so minus 4 y, because second element is for y, and the third element is equal to minus 18. Now we plug in this y value, so x equals, x minus 4 and to y value, which is 5, equals minus 18. Okay, so these two provide us minus 20. When we change the side for it, it will be plus 20 and the x answer will come 2. So it is a unique solution. Now let's see my neat and clean work. If you want me to clean the board, so okay, I didn't do good, but anyway, okay, so R2 y equals 5, and now we will plug in this y equals 5 in the first row, which will be 1x, and after plugging it, and x equals 2. So exactly the same we did. We are done here. Now let's go to next example. This time 3 by 3. So all the three equations get us this augmented matrix. Okay, so there should be planning for the first leading one, and it's very easy. If you see here we have 1, so we should use this one. Here is 1. Okay, so I change these two rows with each other. Okay, row 1 and row 2. So look, just changing their place. Now we got leading 1 in the first. Now we are doing leading 1 for this and leading 1 for this. Okay. So this one is not yet complete leading 1, because under it all of them, this 2 should be made 0 and this 4 should be made 0. So I did what? From the row 2, I'm going to fill in. Okay. This 2 can be made 0 if we subtract from it the first row element multiply by 2. So, and similarly, if we can make it 0 if we subtract from it the first row, this time multiply by 4. So look, second row minus 2 row 1 and third row minus 4 times row 1. So 2 is actually row 2. Look, first element, this is row 2, row 2, row 2 and row 2, and then we subtract and subtract. Then we are using 2 because it can be made only 2 by multiplying 2. So here it is 2 and 2, and the first row element, this is first row element. Look, this is 1, this is first row element minus 3, first row element 3, and first row element minus 4. So this row operation is for that one. Now I'm coming here. So look, 4, I should change the color, this is difficult to be seen. Okay, this is first row element. Okay, then minus and minus, because we are after this 4 to cancel it. So 4 times minus 4 times first row, 4 times first row, 4 times first row, and 4 times first row, and this will make the first one in the first row a leading 1. This one is made now leading 1. Now we are to make this one leading 1. So we divide this by 7, divide this by 7, divide this by 7, and divide this by 7, because we will do same operation to the whole row. So divide whole by 14. But secondly, if you see, this is 7 and this is 14, so 14 minus 2 times 2 times 7 is 0. So we can make it 0 first easily, this 14. So let's go for that. Look, I did what? I have done row 3 first, because we can make easily this element 0 with the help of this 7. What is this? This is actually 7. This is actually 7. Second row, look, this is second row minus 4. This is second row 16. This is third row 17. Third row minus, and third row 4, and third row 0. So you don't need to do with the 0, because here it is 0, so again it will come 0. And now we produced 0 here, so we can easily make this one a leading one by division of. So see, I explained division before, and we can also make this leading one by dividing by minus 5. So this divided by minus 5, this divided by minus 5, and it becomes this. Now this can solve, because this is z equals 3. Z equals 3, and this gives us that y minus, because x is 0, y 4 by 7, this is z, so this is this z, this value is for z, the third one. So here I put the z value, which is 3, equals the right side, which is 16 by 7, and I think if we solve it, this will become 12, 28, and y value will become 4. Do with calculator. Here x minus 3y, so y value is 4. Then this is z plus 3z equals minus 4. This come minus 12, this come 9, so minus 12 and 9 becomes how much? 3 minus 3. Okay, so when minus 3 is shifted to the other side, it will become plus 3 and equals 1. Thank you guys.